Okay, so looking at 2008 higher level question. The four usual types of transformation are here: translation, central symmetry, axial symmetry, and finally a rotation at the end, which most people find difficult. So looking at the shape itself, it's based around intersecting arcs. So when we're translating the points down around the page, what we're going to do is we're going to try and translate the center points for those arcs. So that's going to mean the 2 points bottom left and bottom right, and the point at the top here. So they're the main things we're going to be throwing around the page, and then we can draw our arcs as we go around. So the first type of transformation asked for is a translation from P to P1. So that's the most basic type. It's basically where you take the shape and you slide it down in a set angle by a set distance. So it doesn't flip over, it doesn't turn upside down, it literally just slides down the page. And it's going from P to P1. So in that case, what we do is we join a connection between P and P1, a construction line obviously. We take note of the length between them, so we do that with our compass. And now every point that we move down is going to go down by the same distance, and it's also going to go down at the same angle. So I can set my set square to that angle and slide down my 3 center points that I want to move. Okay, and handily 2 of them are along the same line, they line up with each other. So I take my compass, I go to each of the points that I want to move down, I move along the line, and I mark off where it stops, using the distance from P to P1 as my gauge. And what that does is it finds the location of them down around P1. So that's what I'm going to use now to draw the symbol again. So I can set the compass to radius 30, I think it is, and those arcs will be intersecting each other to recreate the shape. Okay, I'll just go over that a bit heavier. And that's the first type of transformation complete, and that's the simplest type, and it's called translation. So it's just sliding the object down the page. Okay, now we're at P1, and you'll also see the shape maintains the same size as the same sort of shape too. It doesn't go out of shape. That can happen as you go through this question. As you lose accuracy, you can tend to the measurements can go off, or you can lose a shape and you lose marks that way. So try and be as accurate as you can. That's the first transformation done. So my next transformation is called central symmetry. And central symmetry basically means I'm going to pass it through a single point. I'm going from P1 to P2. So what I will do first of all is join a line between those two. Now I'm going to pass it through one single point. The point that I'm going to pass it through is going to be halfway between P1 and P2. You will be expected to do your bisection of a line method to find that center point, rather than just measuring it. So for full marks, bisect that line to get the exact center point. I'll use this compass instead. So I'll just mark that as point X. And now what's going to happen is my 3 points that I want to move up here are going to pass through point X. So what happens is you turn the shape upside down. Now in terms of marking off a distance, what you're going to do is you're going to go to point X. You're going to set your compass over to where the point you're moving is, and you're going to flip it over on the other side. So each distance will realistically be slightly different. And again, these are the types of questions where you can lose accuracy very easily, so try and keep it as neat as you can. Go back and set your original radius of 30 to draw the shape, and again our arcs are going to be crossing over each other. So I'll do it lightly to begin with. And then when I'm happy with the shape, I'll go over it slightly heavier. So you can see the shape turns upside down, and that tends to happen with central symmetry. Okay, so that's P1 to P2 now complete. And again, I'm maintaining my accuracy as I go through. Next type of symmetry asked for in this question is what's known as axial symmetry. Again, this is quite straightforward. Basically what we're going to do is we're going to take the shape that we have currently and we're going to fold it over. And it's going from P2 to P3. So in order to do that, what we do is we join a line first of all. Same first step all the time. This time we're going to find the bisecting line again. So we're going to get the halfway line between them. Rather than just looking for a single point like we were the last time, we're actually looking for a line that cuts through it halfway. So that bisecting line is going to act as our axis. And what we're going to do is we're going to take our shape as it currently is, and we're going to flip it over that axis down to where P3 is. So in order to flip it over, what we're going to do is we're going to pass all of my relevant points through the axis that I've created, and we're going to pass them through perpendicular to that axis. So that will involve using your sliding set squares, or if you have an adjustable, you can use it. Now we're back to the compass again, and what we're going to do is we're going to go to the axis that we've created. We're going to measure back to each individual point, and we are going to mark the distance on the other side. So we're just realistically flipping it over. So what happens is you get a backwards image, almost like a mirror image of what your original shape was. Okay, in this case it'll turn it from being upside down to being the right way up again. Sometimes it'll turn it from facing left to turning right. It's basically just a direct opposite of what it looks like at the moment. So we go back to our radius 30. And once we're happy with it, we go over it heavy. Okay, and once again, I'm keeping the shape as I go through. And that's axial symmetry complete. Now, the last one, and it's the one that causes most difficulty for students, is a rotation question. 2008 question, this is quite typical of these this topic, is asking you to rotate between P3 and P4. You have to rotate the object clockwise through 120 degrees. Alright? So when we are turning clockwise and we're going from P3 to P4, it means it's going to swoop down towards the bottom of the page like this. That's the direction the hands of a clock would move in. So that's what they mean by that. Okay, so it's going to arc around like so. And it's going to arc around by 120 degrees. The key to answering this question is to think of a triangle. And 2 points on that triangle will be P3 and P4. So what I'll do is I'll just do a rough sketch over here on the left hand side. I'll mark off P4 and P3. Now my object has to arc around clockwise, so it's going to be going around in that direction. Okay, I'll just draw an arrowhead to indicate that. In order to swing anything around, I have to have a point to put my compass on, or a rotation point as it's known. And knowing where to put that rotation point is key to answering this question correctly. If you just hold the compass in your hand, if I have to arc the object around in that direction, well, naturally my compass has to go up here. Okay? If I was to put it down here, I wouldn't match up with the arc that I want to do. It would be going anti-clockwise. So my rotation point must be at the top. So that's kind of key to figuring out how to do this when it's going clockwise. And to go back to the idea of the triangle, I'm going to join P3 and P4. They're 2 points on this triangle that I'm going to make up. The third point on the triangle is going to be the rotation point. It's going to be where I'm going to put the compass. Now, key to figuring out how to draw that rotation point is the angle of rotation that's given in the question. In this case, they tell you it's 120 degrees. That's the angle of rotation. So when you draw your triangle, we want our rotation angle up here to be 120 degrees. That means that the two base angles have to make up the difference of 180, because a triangle has 180 degrees. So if you take 120 from 180, you're left with 60. That means I'm going to have 30 degrees on the bottom left and 30 degrees on the bottom right. That will give me 60, and that will leave 120 for the top angle. So when I'm drawing my triangle, I can come up at 30 degrees from the left, I can come up at 30 degrees from the right, like so, and it'll leave 120 degrees at the top, and that will be my rotation point. And what that will mean is I'm rotating my object by 120 degrees by using that rotation point, fulfilling the question. So to go back to how to actually draw that accurately, we just repeat that process, except obviously we use set squares to do it. So P3 to P4. My rotation point has to be up here somewhere in order to turn around clockwise. And I said my angle is going to be 30 degrees at the two corners. So I'll use sliding set squares. I have a 30-degree set square. You can use a protractor if you want to. And just get a 30-degree angle coming in from the left. Same from the right. They intersect each other. Top here. And that's my rotation point. So label that as point R, and always be in the habit of labelling it, otherwise the examiner mightn't know exactly what you're doing. Also, while you're at it, just write in 120 degrees, just to make sure they know exactly what you've done. So that's where my compass is going to go. Now, I have 3 significant points that I want to arc around in order to be able to draw the object down here. So I'm just going to do them one at a time. And again, this next step is quite important. So one individual point at a time. I'll start with this center point here. I'm going to arc that around in a clockwise direction, like so. So it comes down to this direction here somewhere. Now, how do I know where to stop it? What I'm going to do is I'm going to create a 120-degree angle through the rotation point. So I start it here. I'll draw my line to my rotation point, and then I'm going to go off at 120 degrees off that. So you need a protractor for this. And that intersects the arc at that point there. So that's the one I was looking for. Now we repeat that for the other significant points. So let's say I'll do this one here next. So I join it to my rotation point, and then I go off at 120 degrees from that. Okay, and I still have to arc it around. I forgot to do that. So go to the point, arc it around, and you can see that's where it intersects my 120 angle from that point. So that's it down on the bottom left. The last point to bring down then is this one here. So I'll arc it around first from my rotation point, so down clockwise, And then I'll create a 120 degree angle from that through the rotation point. So draw the baseline first of all, get the protractor and measure accurately 120 degrees, and it'll cross over the arc that I just brought down. Okay, so that's the 3 points brought down. I'll go back, set the compass to radius 30 and draw the object again. And that's really typical of any year in a transformation geometry question. There's nothing else comes up on that topic. So if you can understand that, you should be able to run through any question related to it. What also might be a good idea, and you definitely won't lose any marks for doing it, would be to write down each translation as you do it. So label it on the sheet as you're going through it. As long as you write it neatly, use capital letters, all the rest. You could write translation up here, you could label the next one as central, you could label the third one as axial, and finally you could label your rotation here as well. Okay, you're definitely not going to lose any marks for that. So that's the 2008 higher level question complete.